video we talk about absolute value equations. Now it's absolute value inequalities. Let's see that one. There is an absolute value of x. It's less than 3. That means our numbers, the distance between our numbers and 0 must be less than 3. So 3 is not equal. As you see, there is no equal sign. So 3 is not equal. So that cannot be my answer. So 3 and negative 3. Why? Negative 3, absolute value of negative 3 is 3. So when I choose a number, the distance between 0 and my number must be less than the distance between that. So 0, and it must be smaller than that one. So let's choose a randomly number. It's really clear. If you choose a number this side, so let's choose x, it will be more, it's longer than 3. So same idea. If I choose a number from here, again it will be more than 3. So I cannot choose any number far away from the negative 3. So this means less than negative 3 or more than negative 3. So what will I do here? It must be near around the 0, not far away from the 3. So if I choose any number, let's choose a number here. So x, as you see, the distance between 0 and that number is less than 3. So, or if I choose a number from here, as you see, the distance between a number and 0 is again less than 3. How can I know? As you see, that's smaller than the red line. So that's all. So what can I do? I can tell you, I can choose any number. I can choose any number here. It must be that side or that side. So what can I say about these numbers? These are all x. What can I say about these x? These x are greater than negative 3. So my number must be negative 3, greater than negative 3, and less than 3. So any number, if you choose here, it will be greater than negative 3 and less than 3. So if you remember compound inequalities, that look like, okay, this side is my solution and its end situation. Greater than negative 3, less than 3. What about if it's greater than 3? So that's a good question. Again, I can say if it's equation, usually we will use 3 and negative 3. I'm sure 3 and negative 3 is equal to 3. So I want some numbers, the distance between 0 and the number will be greater than 3. So which numbers are there? Let's choose here. Okay, that part out. Any numbers here. Yeah, that color wasn't good enough. Let's draw from here. Any numbers, not 3, but this side. If you choose any number, it doesn't matter what number is it. Let's choose 5. The distance between 0 and this 5 is, I am sure, greater than 0 and 3. Any number, if you choose right side of the 3, greater than 3. So that's numbers it will be x, and these x are greater than 3. So look at the left side. If you choose any numbers again, here, less than 3, so the number is minus 4, minus 5, minus 6 is less than negative 3, sorry, not 3, negative 3. The distance between 0 and these numbers, let's choose here a number, it doesn't matter, it's negative, I don't know, 4.6 maybe, negative 4.6. Negative 4.6 is less than 3, but the distance between 4 and these numbers is less than the distance between 0 and negative 3. So this is 3, 1, 2, 3. It's more than 3 units. So I can say the number must be here on left side of the negative 3. All these numbers and all these numbers is correct for this inequalities. So what can I say for that one? It's an OR situation. Let's clean everything around my solution. So I don't want this part. I don't want this part either. Okay. What's happened? The left side and the right side. At the middle, nothing. It's remind you maybe OR compound inequalities with OR. So what can I say? a number must be greater than 3, or as you see this side is less than negative 3. X must be less than negative 3. You can write it x is less than negative 3 or x is greater than 3. This is an OR situation when it's bigger than a number, so we will think about it's an OR situation or statement. Let's solve one example. Here an absolute value we have, and I don't know about this absolute value because there is a plus 1. So let's get rid of this plus 1. When I take away from both sides of inequalities, this sign will not change. What I have here, x minus 2 is less than 3. So this absolute value, if it's less than 3, so it must be greater than negative 3. First example, remember, minus 3 is less than x minus 2 inside the expression, and it must be 3. So I need to solve these inequalities, compound inequalities actually, plus 2, plus 2, plus 2. Minus 1 is less than x is less than 5. You can graph it. You already know how to graph it. I'm not going to talk about that part. Let's solve another example. And this will be the last example about this video. If you want more examples, if it's not enough, if you have some ideas, so you can write a comment. Okay, let's solve that one. Plus 2, plus 2. Here a bit greater than, so you can directly say that will be an OR. So 3 times x plus 1 is greater than or equal 6. Divided by 3, divided by 3, that will be 1. X plus 1 is greater than or equal 6 divided by 3 is 2. Let's solve it here. That means my number x plus 1 must be less than, x plus 1 must be less than or equal negative 2, because there is an or equal, so I can keep this or equal is equal to, the distance can be equal to, negative 2 is equal to actual absolute value negative 2. So or x plus 1 is greater than or equal to, that's all that one, minus 1 minus 1, x is less than or equal negative 3, or x is greater than or equal 1. That's our solution set. You can graph it with or here and or, don't forget it. Thanks for listening.